All right, Julian, we are ready to roll.
Okay, so you can hear me good and everything?
Yes, yes.
Okay, great. So like Nora said, the last couple of weeks, apologies for what happened. I'm not sure what happened. I think it was on my side because I was using my Zoom on the same computer.
Julian, I don't know, but even now I can see you talking, but your voice is not coming out clear.
Okay, let me see something.
Please, quick suggestion. Every other person can just mute and unmute when you really want to say something. Please, I think it's going to help.
Can you hear me a little better?
Yes, this is better.
Okay, but yeah, like I was saying, Hog, so yeah.
It's coming on and off.
So I think the problem should come from your mic or something like that, because when you speak slowly, it comes out good. But when you start talking, they will start having some kind of breaks like in your speech and everything. So your movement, your picture movement, everything is fine. So I think it's from your mic. You can, if you have another mic, you can change your mic from your own side, Julia.
Yeah, let me see if I can change my mic. Give me a second.
So guys, while he's preparing his mic, we'll just plead on everybody to put yourself on mute, just so we have a clean line. So if you're not talking, please just put
Doctor, even you too.
yourself on mute, so we don't have.
Okay, so can you hear me a little better now?
Oh, we still got the noise.
What kind of noise is it?
I think it sounds better now.
Which is going in the background?
It sounds like a beat, like a drum or something like that. You know, when you start going, it feels like, you know, like it's a beat.
Like music battery.
Yeah.
Hold on, let me see. Maybe it's the fan that I got on. Give me a second. Okay, is this better?
Very, very much better.
Okay, I see what it was. It was the fan that I had in the background. I didn't think the fan was gonna make that much of an effect. So you can hear me good now while I'm speaking faster, right?
Yes.
That was the fan issue that I had.
Start it.
Julia, so sorry for cutting you off, Doctor. I'm so sorry, guys. Can you? I think this problem is coming from either something is touching, either your mic, the cable you're the cable being plugged to your computer is a problem or something like that. Or if you have a phone, if you want to connect using Zoom, connect with your phone. Let's try it and see. You talk to us and see. I think something is wrong. This thing is from the computer or something like that.
Okay, let me connect with my phone. Let me turn this audio off because I'm using my my webcam audio for this. So maybe that's the reason.
Hello, Julian, can you hear? Can you say something?
Okay, how well can you hear me?
I think it's good. We can hear you, but you should probably mute the laptop now.
Echoing.
Is it echoing too? Yeah, I hear it.
Yeah, it's still echoing.
So I think you just need to go on one of the device, probably the laptop, and then mute the mic and also turn off the audio from the mic, from the computer. And then leave it directly on your phone, and then everything should be fine.
Right. Can you hear me now?
Yes, I think that's better.
Great. Okay. Perfect. All right. So you can hear me really good now, right? Like it's no kind of echo, no type of sound issues or anything going on.
Yeah, this one is better, Julian.
Okay. Perfect. All right. So let's get started really quick. All right. So first of all, what I'm going to be doing is performance troubleshooting using execution plans. Right. First of all, thanks, Norris, for this invite. Again, I look forward to getting to know this community. And like I said, the name of this presentation is Troubleshooting Using Execution Plans. And the goal is to give you a checklist on how to troubleshoot trouble queries using execution plans and implementing indexes where needed. All right. So before I get started, here's some information about myself. My name is Julian Remy, Senior Database Administrator at Wells Fargo. I've been a DBA for about 8 years now. Currently, I'm only on SQL Server, but in the past, I've worked DB2, Postgres, and Oracle. Spent whole career in the financial institution. I'm an MCSA, SQL 2016 certified, and I specialize in database migration, performance troubleshooting, and PowerShell automation. Those are the three specializations that I work with the most. So my Twitter handle is @Jules_Remy. My email is jremy1@gmail.com. And my LinkedIn account is the LinkedIn/n Julian-Remy. If anybody wants to reach out for anything, any questions about this or anything. All right. So performance troubleshooting using the execution plan, right? So before I go into that checklist, right, there's some things that you need to understand or some topics that you need to understand. So I'm going to give you an overview of it. I know this is a beginner's class, so that's understandable. And that's why I'm going to give you an overview of these different things before we look at the checklist and go into examples. So the first thing I'm going to give you an overview of is what is an execution plan. and a query optimizer. What is statistics IO? Because that's a tool that I use when it comes to, you know, performance troubleshooting query in the execution plan. What is a heap, a clustered index, and non-clustered index, right? So I'm going to give you an overview of this because in these examples, I'm going to be putting clustered indexes or non-clustered indexes on the trouble spots, quote unquote, in order to fix some of the issues. I will say you can't fix all issues with clustered indexes or non-clustered indexes, right? There's two ways to really fix an issue when it comes to a query. It's the indexing. You can put some indexes on it.
I'm in class. Please, can you?
Say that again. Somebody said something?
No, you're good. You're good. Go ahead.
Okay. Yeah, so it's two main ways to really fix the query if it's having, you know, performance issues, whether long running query or whatever, right? Is, you know, putting a index on it, whether it's a clustered index or non-clustered index, or it's actually, you know, tweaking the query, right? So in this class, in this topic, we're gonna solely use the indexing part of it, right? We're not gonna touch the query. We're not gonna manipulate the query at all. We're all gonna use just the indexing part of it. And then finally, how I read execution plans to performance issues with examples. All right. So let's get into it. Before I get into it, does anybody have any questions? Right now, you can see everything good and all that stuff. Everything looks good.
Yes, we're good.
Great, I'll take that as a yes. And no questions currently, right? In silence, I just take that as a yes if I don't hear anything. All right, so like I said, the first thing we're gonna go over is an overview of what an execution plan and query optimizer is, right? So an execution plan reveals to us how SQL Server decides to retrieve the data when you run a query. Basically, it's the blueprint of the query, right? So you run a query and no matter what, there's an execution plan behind it that's telling the query how to run, right? So that's what an execution plan is. But there's something behind there that picks the execution plan, and it's really the brains of it. And that is called the query optimizer, right? So the query optimizer, think of it like, you know, a manager or something like that. It asks questions before the query runs, like, you know, how will I send my workers to get this data, right? Because it has a bunch of execution plans that it can pick from. So it's like, how would I send my workers to get this data? Will I send one or many workers, right? And so that's called parallelism. And I suck at saying this word, by the way, so forgive me when I try to say parallel or parallelism, because it's one of those tongue twisters, right? And I'm gonna say it probably like 2 or 3 times in this presentation. So when it's asking, will I send one or many workers to get this information, right? To get this data of this query, that's parallelism. And that depends on how many cores you have on your computer. So for example, if you have 2 cores on your computer, the most that the query optimizer will send is 2, because you have 2 threads that you can run on, right? So it asks questions like that. Ask questions, will I have my workers use indexes? Are there indexes available, right? So it asks that because, like I said, that's one of the ways to speed up a query or make performance better in a query, right? So it's gonna ask that question, is the right indexes available here? If they are available, would it make sense to use this index or use something else, right? So it asks questions like that, and within a good amount of time, it picks a good enough plan, right? So a lot of people feel like, you know, when it comes to the query optimizer, it picks the best plan possible, right? I mean, the best plan period, but it actually does not pick the best plan for the most part. It picks the good enough plan, right? And so you have to ask yourself, right? So for example, the reason why I picked a good enough plan versus absolutely the best plan is because take a query, for example, right? That runs for a minute, right? You know that it's gonna run for a minute, or the query optimizer knows that it's gonna run for a minute at most with the worst execution plan, right? But it takes 5 minutes to go through all of those execution plans to pick out the best one. If that was you, if you was a query optimizer, won't you just say, I'm not gonna spend 5 minutes looking at all of these plans to decide which one is the absolute best one? I'd rather just spend 10 seconds picking the good enough plan in that time amount so I can run it, and more than likely and hopefully it will be a plan that runs under 1 minute or at 1 minute, right? So 1 minute and 10 seconds versus 5 minutes is always better. So it picks the good enough plan. It doesn't pick the best plan per se. Now, sometimes it might pick the best plan, who knows, but I'm just saying, I'm just emphasizing that not all the time it picks the best plan. It's just a good enough plan within the time that it has allocated to pick a plan, right? So like I'm saying right here, the purpose of the query optimizer is to find an efficient execution plan for your query in a good time. And finally, you read the execution plan from left to right, top to bottom. I have an execution plan right here. Tell me if you guys can see this. I know it's kind of small, right? And I'm actually going to zoom it a little bit as well, just so you can see an execution plan if you've never seen one. So this is the execution plan, a SQL Server execution plan, right? And no matter how big it is, you always read it from right to left, top to bottom, right? So let me zoom over here so we can see the one all the way to the right. All right, so this will be the first one right here. This clustered index scan is the first operator that's being ran, right? So this is number 1, number 2, number 3, and then here is number 4, right? So it's from right to left, top to bottom. That's how you read this. Any questions before I move on to the next section?
Can you repeat yourself again, this last part?
Say that again.
Can you repeat yourself again from this last part of it when you said read from the right to the left?
Okay, yes, definitely. So, like I said, if you look at an execution plan, this is the execution plan as a whole, right? I can zoom in over here, right? So the select statement is here. A lot of people, and the reason why I'm emphasizing this, that you read from right to left, top to bottom, a lot of people will come in here and see the select statement and think that's the first thing that's being read, or you should start here when you're looking at an execution plan, but that's not the case. That's the end. The last thing that the execution does is select the data that you're wanting to display, right? The first things are done all the way to the right side over here. So here's the first thing, the very first thing. If you want to know the very first thing that this execution plan is doing, you go all the way to the right and the top. And so this is it right here. And we'll get more in depth of these operators as well. I'm just showing you, how to read it from, right to left and top to bottom. And like I said, this is number 1, number 2, number 3, number 4, right here. Then number 5, number 6, number 7. You keep on going, 8, 9, 10, 11, 12, and 13, 14, 15. That's how this is executed. That's the order that the query is being, or the execution plan is being executed when you run a query. So did I explain that well, or do you need more explanation?
Yes, it's clear, Julian.
Okay. All right, so when it comes to the execution plan, there's 3 types of execution plans, right? There's the estimated, there's the actual, and there's the live execution plan, right? So the first one, the estimated, gives you the estimate of the plan only. It's not executed and no results, right? That's the first one. And don't worry, I'm going to show you an example after I state what the actual execution plan is. The actual gives you the estimate and actual results of the plan. So the only difference between the estimated and the actual is the actual gives you the actual information, right? Like how long did it run? The actual number of executions, it's a lot of stuff, but I'll show you an example right now. Let me take this query that I'm running here and I'll put it on another screen. All right, so if you want to run the estimated execution plan, this is the button right here, display estimated execution plan, or you can press Control L. I always just press this button. So let me run it. It's going to display the estimated execution plan. It's actually taking a long time for the estimated execution plan. Did I click the right button? Let me see something. Yeah, I did. Typically the estimated execution plan shouldn't take this long. I'm not sure why it's taking that long, but I'll let it run, and when it finishes executing, we can do a comparison. Let me go back to this part though. Where is it at? Yeah, this is strange. I'm not sure why it's taking so long to run. Give me a second. That's strange. Give me a second. Let me just test another one out. Because like I said, when it comes to the execution plan, the estimated one, it shouldn't take too long because all you're getting is the estimate. It's not actually running anything. It's just giving you an estimate. The query optimizer is just, devising a plan, picking the right execution plan, and just showing you it. So it's not doing too much. Like I said, when it comes to that, asking yourself is, should I take a long time to, find the right execution plan, or should I, pick one fast and execute it? And this one's looking like it's taking a long time to find the right execution plan. Let me test this one really quick and see what happens. Oh, actually it's done. All right, it's done. Anyway, I'm not sure why that took so long, but it took a long time to get this execution plan. I'm going to compare it with this other one. Okay, so on the left side is the actual execution plan, and on the right side is the estimated execution plan. Let me blow this up a little bit more. So the only difference between the two is the actual, for the actual execution plan, you get actual information. So as you can see on this tip right here, it says actual execution mode, which is row. You know, actual number of rows for all execution, actual number of batches, right? If you look here as well, it gives how long the operator ran for. So this one ran for 10 seconds and 10 minutes and 5 seconds, it looks like. Yeah, this gives you the actual versus estimated number of rows to this 7641. I think this is 1,213,000, something like that. 121,335, right? So this number right here is actual estimated. So how you know actual, how do I know that the top number is actual and the bottom number is estimated? Is I say A comes before E in the alphabet. And that's how I know it when I look at this. Numbers like this is really important when you're looking at an execution plan. When you do the estimate, you don't get any of this information, right? And that's why most people, they prefer the actual execution plan. Most people don't run the estimated execution plan unless the query is taking a very long time to run, right? Because like I said, the estimated execution plan will, you know, is way quicker, like it produces way quicker than the actual execution plan because everything has to run before that execution plan is showed. And so that's the only reason why you would want to look at the estimated execution plan if it's a really long running query and you want to see what SQL Server, the query optimizer, plans on running for your query. All right, and so actual plan is the estimated plan with additional runtime details like actual number of rows read and any warning sign. This runtime detail is usually key to finding issues that will show up in examples. All right, so the final one is a live execution plan. I wish I would have kept that one open. I'm probably gonna have to run it again so I can show you the live execution plan. Let me get that open again. So a live execution plan is essentially, it's showing you the operators in live action, right? So let's say you have a query that's running a long time. This shows you what operator is taking so long to execute, right? That's the really good thing about a live execution plan. So I'm going to show you that really quick. Give me a second. Let me get that query again. There it goes. All right, and so for the live execution plan is this one right here with the check mark. And I'm going to run it. And if you can see, I don't know if you can see that, those ant trails. Can everybody see those ant trails? Those ant trails are telling you that this is running currently, right? So the ant trails right here, like I told you, the first thing that runs is all the way to the right and left, right? So those ant trails are telling you that this is running right now. And that's the great thing about a live execution plan. You can see exactly what's running and possibly what's holding up your query so you can know what to tackle. That's what's important about a live execution plan versus all the other execution plans. And while we're talking about this, let me say this as well. When it comes to SQL Server Management Studio, SSMS, it's always better to have the most recent version, right? The reason why you want the most recent version is because they always updating this stuff with really good information and really good tools like live execution plan, like, you know, how long the optimizer is running things like that that's not in the older versions of SSMS. With the most recent SSMS versions, you can run those on any version of SQL Server, minus SQL Server 2008 and possibly 2012. I'm pretty sure 2012 you can run the most recent SSMS on as well. So I advise you to always, unless you can't, right, always get the most recent version of SSMS so you can have these type of tools when you're troubleshooting a query or anything like that. As you can see, this clustered index scan right here is taking a long time to execute. So I would know, okay, this is probably the first thing I need to look into and figure out why this is taking so long right here. So that's what a live execution plan is right there. All right, so before we move on to the next section, does anybody have any questions of the difference between estimated versus actual versus live execution plan? All right, I'll take that as a no.
Excuse me,
Next,
I have a question
Mhm.
though. Yeah,
Yes.
my question is not on the live execution plan, but I want to ask, how can I use this execution plan to determine if I'm having a bad index or I haven't updated my statistics?
Right, definitely. We'll go through this. Right now, all I'm doing is giving you an overview of the tools that I'm going to be using. You know, because I'm looking at this as a beginner class. This might not be a beginner class, but I'm looking at it as a beginner class, right? So I'm looking at it as, you know, you don't understand what, you know, some of these things are that I'm going to be using. So I'm giving you an overview of it before we actually go into it. But as soon as I give you an overview of these, we'll go into that and I'll show you, you know, how to, you know, look at that and what to pinpoint.
Hey, Julian,
Yes,
quick question.
yes.
So from what you're saying, if you want to run a query, you want to first of all start by running the estimated query plan. So now when you run it right, you don't have anything, the results to compare with to know if it's good or bad. And I don't know, what do you compare it with after you run the estimated to know that it's good, you can use it or.
You said after you run the execution plan, what do you compare it with?
The estimated, you know, so when you estimate something, say it takes 3 minutes or let's say 3 seconds, right? So how do I know 3 seconds is good or bad? Because I have to compare with something.
Okay, so how do you know if something is good or bad? We're DBAs, right? So the application team or somebody's going to come to you and say, hey, I have a slow running query. Or if you're a developer, right, you created a query, you run the query, even if it's running for a second, you know that's not up to standards, up to your standards or your team standards or your company standards, right? So it's two ways. If you're a developer, you know what's up to not as far as like how long the query is running. And secondly, if you're a DBA, a true to form DBA, the app team's gonna reach out to you and say, hey, my query's running long, or the server's running long, or something like that, where you have to look at a specific query. So that's, ultimately, it depends. Like, you know, that's the big thing that DBA say, right? Everything depends. And that's the same thing for this. It ultimately depends.
Okay, so let me put it this way, right? A good query, standard query, right? Where you work, how long does it supposed to run? And you say this is good.
So you said a good query is what?
A good query, right? Like, so you run a query, it runs on like, right? Where you work is standard. How many seconds is it supposed to run? And you say this is good.
Right. So that how many seconds it's supposed to run is ultimately, so okay, at my job, right? We get this, you know, I've got this a couple of times, right? Where a team, and matter of fact, I'm working with a team right now when it comes to queries. They come with a couple of queries, they're saying, or store procedures actually. There's actually a couple of store procedures. They come with those store procedures and they said, hey, these store procedures are not running the way they was running on our old server, right? And so what I'm doing right now is I'm looking at those queries or store procedures and I'm going through my checklist and looking at the operators. And like I said, don't worry, I'm gonna go through my checklist on what I look for, right? But essentially what I do, no matter how big or small the execution plan is, I'm going through my checklist and looking for, you know, certain things. And I'm gonna specify those certain things a little bit later in this presentation. But I'm looking for specific things that I know, okay, I see this might be an issue, or this might be helpful if I put an index on it. There's certain things. And like I said, the reason why I'm not specifying it now, because in probably about 5-10 minutes, I'm gonna go over it.
Okay, thank you.
So any more questions? All right, so perfect. This is the last section right here. So right after this, I don't know who was talking, but right after this, literally we're gonna go through what you're asking. We're gonna go through that checklist. So final section, what is a heap, clustered index, and non-clustered index, right? So a heap, first of all, a heap is a table. When you first create a table, if it doesn't have a primary key, the table is gonna be a heap, right? The heap is not ordered. It has nothing for a query optimizer to really, you know, seek into. There's two things when it comes to a query optimizer, right? You're either going to seek into it or you're going to scan it as far as the table, right? You ultimately always want to seek into the data that you're looking for. A scan is typically not the best way to get information out of an optimizer, right? And when I say optimizer, I mean this right here. This thing that's highlighted, this is the optimizer. You typically want to seek into that optimize or into that object in order to get that data, right? When it comes to a heap table, I don't care how big or small that heap table is, you're always scanning that entire table, right? And the reason why is because it's no unique identifier in there. It's no index key value. So when SQL Server goes in there to pick up information, it doesn't know when to start and when to end looking for that information. So it literally has to scan that whole table. So let me show you how this essentially looks. Y'all can see that, right? So this is a heap table right here, right? The IM is basically the guider that guides the index, or not the index, that guides the execution plan on what to look for, right? So that's what the IM is. It always has to go back to the IM to look for information. So literally, right, it comes to this IM and it goes and collects the information. So it asks the IM, hey, where is Julian at in this table? The IM says Julian is in this header right here, right? So it goes there and it looks all in here for that. If it needs some more information, it has to go back here and ask that question again. Hey, where is this at? Oh, this is here. So we got to go in here and get that information. It keep on doing a back and forth, right? And it has to do this for the entire table. It scans everything. No matter what, it has to scan everything. There's no start or finish to this until it scans everything, right? And so that's the big issue with a heap table. And that's why typically you don't want a heap table on your table. You want to put at least a clustered index on it. There's definitely, you know, times that you want to have or that you may not prefer having a clustered index on your table, but 9 times out of 10, you want to have at least a clustered index on your table, right? And I tell you this because that's part of troubleshooting as well, when you're troubleshooting a table or troubleshooting a query. All right, so the clustered index. So what is a clustered index? First of all, there's only one clustered index per table. Typically only one unique column, which is an index key value on the table. So they only allow one clustered index on the table, right? So when created, that replaces the heap table. So no longer would that table be a heap table at that point once the clustered index is placed on there, right? And the clustered index is the entire table, and it's ordered by a unique column, which is the index key value. And when I say index key value, is usually the, you know, the primary key, right? That's usually the index key value. And a table for clustered index is almost always better than a heap table, like I told you. So let me show you basically what a heap table, a clustered index is. So this is a clustered index right here, right? And what I'm saying is no matter what, 9 times out of 10, a clustered index is always better, is because first of all, you see these previous and next marks, right? So when you're looking for data, right, you don't have to go back to the root node to ask, where is this piece of data at anymore. You have a mapping here within the page that guides you to find that data, right? So let's say you have to do a scan. Like I said, there's 2 ways to, look for data in a page, right? You either seek into it, and a seek on a clustered index would literally be, you come here and you just seek right to where that data is, right? You don't go and touch nothing else. You know exactly where it is because this, the root node tells you, okay, this is where that data is right here. And you just seek right into it, right? If you need to find more data, you have these previous and next guiders that will guide you to the rest of that information. So for example, let's say you find in all names that all last names with Smith, right? The first thing that you're gonna do is if you have a clustered index and the clustered index is on last name, right? The clustered index has to be on that last name. It's gonna seek into, did I say Smith? I didn't say Smith, but let's say Smith. It's gonna seek into Smith, right? So let's say Smith is right here. It's gonna seek here, and it's gonna just collect all the Smiths, right? If more Smiths is on the next page, it's gonna go to the next page and collect all the Smiths as well. If there's still some Smiths on the next page, it's gonna go to that next page and collect that, right? So that's the big difference. It doesn't have to go back and forth, back and forth, back and forth. And because it's ordered by Smith, it knows where to stop at, right? So if Smith ends here, it knows, okay, I'm done. I seeked into everything I needed and I'm done at this point. So I can go back, right? If this was a heap table, what if Smith was on this table as well? In this page as well. Nobody knows because it's not ordered by anything, right? If it's here, that means I have to check here because I don't know if it's there or not. So it's going to check here as well. and all of that costs money, performance, and it takes time, right? So that's why a clustered index is always better than a heap, 9 times out of 10.
Julian, somebody have a question.
Yes.
Somebody asked on the chat that is there a situation where a non-clustered index is preferred over a clustered index?
Yes, there's a lot. So that's the next thing I'm talking about, right? So the clustered index is only one. You can only make one clustered index, right? And typically, if you have a primary key on your table, the clustered index is automatically made. That's how much SQL Server and Microsoft trust clustered indexes over heap tables, by the way. So let me open this up. Right? So you see this primary key. This is the primary key of ID, right? If we go to index, you see this PK link types ID clusters. I didn't make this. If you go to any of your tables, you can go to any of your tables. If you have a primary key, you have a clustered index, because Microsoft says that 9 times out of 10, having a clustered index is better than a heap. So we're going to automatically create that for you, so you don't have to worry about it, right? So when it comes to a non-clustered index, that's when you want to specify, you have a certain query that you're running or that somebody's running, and you want to make an index specifically for that query, right? There's something in that query that if you put an index on it, it will make it that much faster. And like I said, we'll go through that. I'm going to show you examples of that. Like, for example, this is a clustered index scan, right? We're going to go through this and we're going to put a non-clustered index on here more than likely. So you can see what happens when you switch up from a clustered index to a non-clustered index that specifically, like targets exactly what this is asking for. So yeah, to answer your question, there's a lot of times where a non-clustered index 100 times better than a clustered index. A clustered index is just the beginning of indexes, right? A non-clustered index helps you out when it comes to specific types of queries that you need to run that would possibly need some help.
Okay, I do have a question. So
Yeah.
So is it advisable to use a clustered index on a small table?
Right. So depends on how small the table is, right? So situations like that. So for example, when you're saying small, if it's just 10 rows, it makes I would say it makes no sense. But the general rule of thumb a lot of people follow is, if I'm going to put an index, a clustered index on one of my tables, I put them on all of them, because it doesn't cost that much per se, right? Like the cost of it, there is a cost, by the way. So let me tell you about when it comes to indexes. There's a cost when you're doing things like, inserts, updates, stuff like that, because you literally have another table. Look at it like you have another table that needs to be updated, because all the indexes is a smaller version, typically a smaller version of your table. So if you do a lot of updates, that's why I said 9 times out of 10, right? So if you have a table that does, 1,000 updates per day, and it only queries that table or, selects from that table 1 time a day, in that situation, it might be better, not to have a lot of indexes on your table, on that table, right? It really all depends on, the person that's, creating these indexes as well. Like, it's essentially, okay, I have this index, I run updates on it, 100 times a day and I only query it 1 time a day, do I take that 8 minutes that it takes to query it? Am I satisfied by those 8 minutes that it takes to query it? Or do I need to put an index, 1 or 2 indexes on it, and that would slow down my updates by, a couple of seconds? Does that make sense to do that? Or do I not want my update to be affected at all? And all I do is, when I run that query at night, I'm perfectly fine with getting that data in 8 minutes or 10 minutes or whatever, right? So those questions right there, you have to ask yourself when you're in situations like that. But like I said, 9 times out of 10, it's better to have at least a clustered index on it, because when it comes to a clustered index, that's just one, right? It's not 5 or 6 non-clustered indexes on there, and typically is better than a heap. But yeah, in a situation where it's 10 rows, that might not make sense. But how many you have with 10 rows? There I can see tables, but so you have to ask yourself that.
All right. Thank you very much.
No problem.
Excuse me, I have a question, please. So
Yes.
talking about this clustered and non-clustered index, let me give an example. If your instance, for example, or let me say if you have a DBA that is giving you a data and you see that tuning is one of them. So after doing all the analysis you've spoken about and stuff like that, sometimes you may get a recommendation maybe from the DBA to, maybe do or install a non-clustered index, and you're not battling with it because you already have indexes, on there. First of all, you have your clustered, and maybe you have 1 or 2 already, and you have a lot of transactions, maybe almost 6 million transactions that go through that, maybe in a day or more, and it's slow. And what do you do? Because I think with what you're saying is like there's a fine line between creating the indexes. It's either you create it and you still have a lot of weight or maybe performance issues. Should you go ahead and install them because you need it, and DBA is telling you to actually maybe install a non-clustered and you already have one, and maybe you need more because the table is really huge. So how will you really determine, should I go ahead and do it? And this is what the DBA is saying and all of that. Like, how can you really balance it?
Exactly. Okay. So I wasn't planning on getting into this, but since you asked this question, we can get into this, right? Okay, so when it comes to non-clustered indexes, kind of knowing how much non-clustered indexes you should have on a table, right? Yeah. There's a general rule of thumb that somebody, I don't know if you guys know Brent Ozar, right? But he has this general rule of thumb, which is, 5 indexes, per table, 5 non-clustered indexes per table. And the only reason why he says 5 non-clustered indexes is literally because he has 5 hands, right? 5 fingers, I'm sorry. So that's the only reason why he has that general rule of thumb, right? Is because he has 5 hands, 5 fingers. So I say that to say this, right? 5 is what I go by as well, right? If I look on the table and I see there's, 5 or more on that table and they're asking, for another index to be placed, the first thing that I do is I see if there's an index there that already handles the issue, right? And what do I mean by that? There could be an index there that, covers 1 or 2 of the columns, but the main column that I needed to cover is not part of that index. That's when you go into something called a covering index, right? And all a covering index is where you literally add that column to that index. And when you add that column that's calling for that index to that index, it will use that index to query or to get that information out of, right? So that's the first thing I'll look at. I'll see if I can do a covering index. If there's no covering index on there, right, I'll look into it, and there's some queries. I can send you some queries, right, as well, right? I'll see how often those other indexes on that table are being used, right? So there's a lot of times where, you know, teams, they just put all kind of indexes on the table, and they just put it on there for no reason. For example, let's say it's a vendor tool. The vendor puts a bunch of indexes on there because they say in the future you might need this index, so we're going to put it on here and don't worry about it, right? So if I see something like that, I'm going to query. Like I said, there's a DMV that you can query to see how much time or how often those indexes are being used. I suggest that if you run a query like that, you run it over like a, you know, at least a couple of days, right? You want to run it for at least a week to see every day if it's being used or not. Because once a SQL Server engine is restarted, that calculation is restarted as well. That time, that ticker, that counter is restarted as well. So if you restart your server often, or, you know, your company restarts your server often, you want to look at that over a period of time, right? So you can look at a query like that as well. If you see there's a couple of indexes, 1 or 2 indexes that's never being used, you can say, okay, this index has never been used. I've looked at this for the past week and it's never been used, so there's no need for this to be there. So I can cut that off, I can delete that, and I can replace it with that, right? And finally, if you can't find a covering index, all these indexes that's on there, those 5 indexes that are on there that are being used, that's when you have to, you know, work with the team and ask them, okay, how, first of all, do you guys do any updates? Do you guys do any inserts, the DDL stuff, right? Do you guys do any of that? And how often do you guys do that on your team? Or if you are the developer, you know how often, you know, updates happen and stuff, right? So you're like, okay, if I add another index on here, how much would that slow down the update process? Because remember, when it comes to selects, it doesn't affect the select at all. When you're, you know, running a select query, this is helping select queries. The thing that is detrimental to is, you know, things like updates, deletes, and all that stuff, because it literally has to go to each one of those indexes and do that same update or delete. And so, of course, you know, it's going to take some time. If you have, you know, 5, 6, if you have 10, 20, 30, it's going to take some time to go to each one of those and do that update or delete, right? So that's when you have to have that talk with the application team, or if you're the person, you have to ask yourself, is this one extra index worth, you know, the update process taking a little bit longer? So tell me if that was a good enough answer, or if I have to go through it again.
Yeah, I think that was good, but let me ask another one, please. I'm sorry.
Mm-hmm.
So do you have to, let's say you run a script for that, do you have to check for its efficiency to know if you should take it down or not?
You said you have to check for each execution?
No, I'm saying if you have the script, right? And you run it against, let's say that database that, you know, you're interested in. And you had said you have to look out for its efficiency. No, sorry, I'm asking if you have to look out for its efficiency. From its efficiency, you know if you have to delete it or maintain that index like you're talking.
Right. So when you're looking at that query is telling you how often that index is being used. That's what the I'm referring to. So for example, if it's being used, even if it's being used one time a day or, you know, one time a week, I'm not gonna really consider it, right? Because it's being used. You don't know how much that team needs that query to run fast, right? Or
Yeah.
you're the developer, you know how important that is, right? But I'm talking just totally as a DBA, is information that we don't know, right? So if that thing is being ran, if that thing is being used one time, I'm not really looking to delete that index, right? But
Okay.
if it's not being ran at all, I'm looking to delete it, right? Of course, I'm going to talk to the application team or whoever needs to be talked to, right? But I'm looking to delete that index if it's not being ran at all.
Okay. Thank you.
No problem. All right, any more questions?
Yes, I have a question.
Yeah.
So my question is that in a situation whereby you have a query that's been running previously, like previous days and weeks smoothly, and the next day you come to work, you find out that this query is it's not running anymore. It's taking a lot of time to run. So my question is that what do you do in this section? What do you do? How do you take care of this? Do you I have two questions anyway. So what do you do in this one? Then I'll ask you. If you tell me the answer, then I'll be able to ask you a follow-up question.
Okay. So first of all, you guys are asking really good questions. So when it comes to this, right, the first thing that pops into my head, and I wasn't planning on going on into this, but I'm going to go into it since you asked. The first thing that popped into my head is parameter sniffing, right? You said a query though, right? Typically, you know, all right, so let me say this. When I think parameter sniffing, it's parameter sniffing is always store procedure, right? We're looking at queries here because, you know, this is a class, this is a, you know, meetup, right? I would say, you know, 8 times out of 10, 7 times out of 10, we're dealing with store procedures, right? You know, so let me speak on the store procedure side, then I'll speak on the query side, right? So store procedure side, if I had a situation where yesterday it was running fast, you know, it was running in, you know, 1 second, and then all of a sudden today, they run it with another parameter, they run it, and it's running, you know, it's taking 10 minutes to run. First thing I think about is something called parameter sniffing, right? And what parameter sniffing is when a store procedure has parameters on it. And what parameters is, you know, different variables that you can put on the parameter, right? I mean, you can put on the store procedure. So with one store procedure, with, you know, one variable, they put like, let's say, let me see the best way to explain this. Let's see. Let's go by states, right? So let's say Rhode Island and California, okay? So let's say the store procedure yesterday, the only parameter that was running was Rhode Island, right? It was finding all the people that's in Rhode Island, right? Rhode Island is a smaller state and it has, you know, way less people than California, right? So when the parameter is put in there, right? Remember I told you about the query optimizer. The query optimizer looks at all that information and says, okay, how much people should I send to do this work? Which execution plan should I use to get this information? It asks itself that type of information, right? And depending on that information that it receives is the execution plan that's going to be ran, right? But when it comes to when it comes to a store procedure, it saves that information in the cache, right? So that execution plan is now saved in the cache. Next day, you run California. Let's get all the people in California. California is the biggest state, so a different execution plan might be better to run for California to handle all of those people. For example, you might want to parallelize, like I said, I suck at that word. You might want to parallelize that execution plan so multiple people can collect that information because there's so much people in California, right? With Rhode Island, you only use one person to do that work, right? And so here go this one person, he has to select all those people, you know, in California, whereas the ideal plan would be, you know, 6 people to collect all those people in California, right? And because of that, when you run it the next day, it was running fast as ever yesterday, but now it's running super slow because the execution plan doesn't match. But that execution plan is stuck in cache. It's always going to use that execution plan. So that's the first thing I think about right there, right? When it comes to a query, if I saw a query, you know, somebody came up to me and was like, hey, I ran this query in SSMS yesterday, and, you know, it was running super fast, right? Today, though, I run this query again, the same exact query, and now it's taking 10 minutes to run. Yesterday, it only took a minute to run. Today, it's taking 10 minutes. The first thing I'll ask is, was this server restarted yesterday? Or was it restarted between yesterday and today, right? And the reason why I'll ask that is because there's something in SQL Server called the buffer pool, right? And what the buffer pool does is it saves query information, right? So let's say you run that specific query, you ran that specific query all day yesterday. The first time you ran it, and you probably didn't notice it, it probably took, you know, 5 minutes to run. But literally, the second time you run it, that thing took, you know, a minute to run. You didn't change nothing at all. The only thing that changed is that that query is now in the buffer pool, right? And because it's in the buffer pool, it's gonna run quicker because SQL Server no longer has to go to the disk to collect that information. It's literally going to RAM. And everybody knows that RAM is faster than disk, right? So it's going to RAM to collect that information now. It's not going to disk anymore, which takes a way longer time. And so the server was restarted. Buffer pool is reset now. You run it again, it takes 10 minutes to run. That's the first thing I'll think about when it comes to a query. And like I said, I explained the first thing I think about when it comes to a store procedure. But those are the first things I think about when it comes to each one of those. And that's the first thing I'll ask, and that's the first thing I'll look for.
So Julia, so in this situation, in this situation, can you, when this kind of thing happen, can you update statistics, or do you rebuild indexes and reorganize indexes? And when you do that, if you have to update, okay, go ahead. If you have to do this, so is it better for you to update statistics or to rebuild indexes?
You should always update statistics if you see something in particular, right? So let me go into this a little bit because we're gonna start going into this anyway. Let me see if I see an example here. All right, so these are kind of looking good right now, right? What I'm looking at, do you see that number? Like these are large numbers. I think these are in the millions, but remember I told you actual versus estimate, right? So this is 1, 2, 3, 1, 2, 3. This is 17,142,000. This is 17,142. Yeah. So you see these two numbers, right? This is actual versus estimate, right? So, and we're gonna go over this when we're looking at these operators. But one way that you can tell if it's statistics that you might need to look at is if these numbers was off right here. So let's say, I wish I had a smaller example. Perfect, here goes one perfect. All right, so you see this right here, right? So actual is 7,667. Estimated is something like 2,456,000, whatever. It's in the 2 millions, right? I see this. The first thing I'm thinking is this might possibly be a statistics issue. I might need to update statistics, but it's two things that you need to think about: updating statistics or putting a non-clustered index on it, right? Those are the two things. When I see this, the first thing I think about is, hey, should I update statistics on here? And so that's the first thing I'll do. I'll go straight to it and I'll update statistics. So let's look at this. Let's just say we're getting into examples now since we're already here, right? So users table, let me go to users table. So users table, and it's using the clustered index, right? So this user table is using the clustered index, which is ID, right? So I look at statistics, and this is the statistics right here, right? So let's open this up. So if I look at it, the two things that you want to look at is rows and rows sampled, first of all, right? So this is great right here. The same amount of rows is the same amount of rows being sampled. What this is saying is that when they updated statistics, they literally went through every row to, you know, get a census. Think about this. This is basically a census, right? Literally, they're going and they're like, okay, what information do you have here? Like, what is this information, right? It's jotting this down, and the query optimizer can use that when it's making its estimations, right? That's why they're writing this information down right here. So the rows that's in this table and the rows sampled is the exact same. So that's really good. I'm like, beautiful, thank you. They're doing the right thing, right? They're doing everything. So the second thing I look at is when's the last time it was updated, right? And when it comes to this one was last updated September 10th, 2018. That was over 2 years ago. 3 years ago. I will tell you this though, right? I haven't updated this table at all. I haven't inserted any information into this table at all, right? Now, in an actual production server, if you saw a table that was last updated September 10, 2018, you should absolutely say, yes, I need to, you know, run statistics on this, right? I see this, I absolutely need to run statistics on this because that might be where the issue is coming from, right? So where is it at? Right here. There, of course, there's a script for everything, right? And you should, I'm one of those people, I live and die by scripts. I love using scripts. Like I said, you guys are asking great questions, so I'm answering them, right? So I didn't have that prepared. But updating statistics, you can do it right here, right? And I'll build out the script right here anyway. And this is the script for it. So I'll just run it. Hold on, let me see how long this thing took. This is a 10-minute, that's the reason why I ran this in advance is because this is 10 minutes, right? So I don't want to like wait a whole 10 minutes for this to run. We're gonna go through an example, but this update, I'm just showing you how to update statistics if you don't know, but you're talking about it, so you probably know how to update statistics. But anyway, yeah, this is it right here, and I'll just run this to update statistics. Hopefully it doesn't take a long time. But all it's gonna do is, you know, update the statistics perfect. It was really quick. Let me X out of it and let me go back and look at it again. Oh, okay. So one thing I should have did is a full scan. So I'll go back and do that. So you see this right here, right? Like I told you, this is what you, if you see this is a good example actually. So if you see this, rows, 246,000, sampled is only 106,000 sampled, right? If you see this, you should be like, oh, maybe that's the issue too, because it's only doing a sample. It's not doing the full, full scan, statistics update. It's only doing a sample of that information. So that could be problematic as well. So you want to do a full scan. So with that being said, I'll go back and I'll do a full scan. Let me write the script out again. And the only difference is you put a full scan here. I'm pretty sure that's it. Or maybe it's with full scan. Perfect, with full scan, right? So now let's run this and see what happens. This might take longer because it's literally doing everything. And I think this has like 2 million rows. So, okay, perfect. All right. Let me X out of that. You can go to properties. Details perfect, right? So now row sample is the same thing, right? I'd love to see that. Great. Next thing, updated April 20th, 10:59, 10:54 my time. I'd love to see that. Now, if I run this again, right? If I really suspected that that was the issue, I would run this again and see if that number changes right here, right? Because now that the statistics is updated, if statistics was the issue here, you would see this number change, right? It would be closer to the actual number. Remember, actual is the 7,667, and the estimated, which the query optimizer estimated, is that 2 million number, right? So if I ran this again, like I said, I'm not going to run it again because it's going to take 10 minutes, right? If I ran this again and this reduced, it would run faster, right? Because the query optimizer knows that there's not that much data in there, right? And so it will run faster once it, goes there. And so that could possibly be the issue. I'm telling you right now, that's not the issue. If I ran it again, more than likely, I'm about 80% sure that this number will stay the same. The only reason why I'm not going to prove it is because I don't want to waste 10 minutes on this. So yeah, that's how I look for, opportunities to update statistics when you're looking in here. But it's always good to update statistics anyway, right? There's a query that you can run, that you can look at your statistics and see the last time it's been updated. You can see that information via a query, or of course you can go in SSMS and right-click the statistics and check stuff out. So yeah, absolutely, it's definitely a good idea to update statistics. So any questions? Any other questions?
Julian, is it okay if I say something that happened at my work yesterday with everybody?
Yes.
Thank you. So I wanted to say that I think you answered Nikki J's question in one of what you just said, but just to support that, we had a senior DBA that did like a refresh on dev, and then someone contacted us and was saying that there was like a wait of 5 seconds, and they were complaining, and we came to find out that just because he had done that refresh, some of the indexes on dev were missing, but those indexes were on prod. That's why there was like a 5 second delay, and it was like an issue. So I had to go and script them, script the indexes from prod and come and run them on or back on dev, and then it was up and running. So that could also be like an issue for maybe performance issues or slow running queries if you did a refresh.
When you say refresh, you mean he did a restore, right? Like he restored the database?
No, like he went on dev and then like refreshed everything that was on a particular database there. So the indexes, some of them there, like all the indexes on there were lost, like none was there after that. But on the production server, it was like there were indexes on there, but on the dev environment and the stage environment, there were no indexes rather there. So they had to script from production and run them on the dev instance, and then a dev environment, and everything was up and running.
Okay. Yeah, definitely. I can see that. Like I said, when you say refresh, you mean like a restore, like they took a backup and they restored it, right?
Yeah.
Or do you mean say, okay, perfect, exactly, yeah, that makes perfect sense then, right? If they wasn't there, definitely had to pull them down. All right, so any other questions? Okay. So let me move on then. All right, so I'm gonna go through this checklist of what I typically do when I get, a slow running query, my checklist that I go through, and then we're actually gonna look at some examples, and I'm gonna, do this in real time, basically. So for my checklist to quickly find issues and execution plans, right? So the first thing I do is collect the following data. First, I see how long the query ran. I see how much rows and columns were created. And the reason why, first of all, let me tell you why you see how long the query ran. The main reason why I see how long the query ran is I just want to, compare it. If I do put an index on there, or if the team does put the index on there, I want to compare it, right? So if the query ran for a second when it was slow, and when you put indexes or whatever you put on there, it runs, for, 0.25 seconds. Obviously, that's a win right there, right? It shaved off like 30 seconds, 0.30 seconds, right? So I look at things like that. That's the reason why I see how long the query ran. I write that down first. See how much rows and columns were created. So what I mean by that is this part right here, right? So this, I see how much rows and columns are created, right? So this one is 7,641 rows, right? And I see how much columns, and I see what's in these columns, right? So these are all numeric. If I saw like a text column that just had like a lot of text in it, I'll be worried as well, right? Because that can slow stuff down as well. If you're collecting, huge columns, it's going to take a long time to get that information, right? So I look at that information as well. So I scan this and I'm like, okay, this is 7,641 rows. This is all numeric stuff. Nothing looks like a huge number, right? So this shouldn't take, a 10-minute run. Like this shouldn't be 10 minutes to run. That's the first thing I'm thinking when I collect those two things, right? So next thing, for some reason, I feel like I didn't go over statistics IO, Joe. I don't know why, but I feel like possibly I skipped that. Do you guys remember me talking about statistics IO?
No, you never talked about it.
Yeah, nope. I must have skipped it, my fault. Let's go over statistics IO right now. So if you look at all my queries, you see this set statistics IO right here, right? I put this on the top of my queries because of this section right here. You see messages. Do you see this right here? Right? So this is what set statistics IO produces, right? So it's only two things that you really need to take from set statistics IO, but it's so important when it comes to, working on queries, right? So the first thing is scan count. And all scan count is saying is how much time did the execution plan or the query have to go into the table itself, right? And what I mean by that is like it had, whether it seeped into that table or it scanned the whole table, how many times did it have to like go into there to get the information? So did it, when it comes to this one, it went into that table 26 times to get the information it needed, right? That's a big number. You don't want a scan count to, you don't want a scan to go into a table 26 times to get the information it needs, right? So when I see something like this, I'm worried. I like numbers more in the single digits. If it's in the single digits, 1 through 5, you know, 10 is getting iffy. Definitely like 5 through 10 is getting iffy. Anything up here, I'm like, okay, there may be an issue. The biggest thing though is logical reads, right? The bigger the number, the more you know there's an issue, and the issue can possibly be handled by an index, by a non-clustered index, or a clustered index, who knows? But more than likely a non-clustered index, right? So what this is, all this is saying is the pages, and let me pull this up again, right? So the pages, right? These are the pages. What it's saying is it's scanning that much pages to get the information it needs, right? So with this, I prefer small numbers as well, right? 192, something like this, I would be somewhat comfortable with, but anything large like this, I'm saying, okay, I'm gonna look at this first. I'm looking at this table first when I go into the execution plan. So I think I have a little bit more of a definition up here. So here's the official definitions right here, right? So scan count, number of index or table scans performed. It could be a full scan, partial scan, or a seek. That's what a scan count is, right? Like I said, it's going into the table. How much times is it going into the table? Whether it's a scan or a seek, is going into that table. Remember I told you about a heap where it always goes to the IM and then it goes back. So for a heap, if this was a heap table, this would be huge, right? Scan count would be huge because it's literally going back up to the IM and then going back into the table, going back up to the IM. And what I mean by IM, let me show you that again, which is this right here. It's going back up to the IM and going into the page, going back to the IM, going into the page. That's what they're referring to here. That's the scan count. Logical read, right? Number of pages read from data cache indicates how efficient the operators are reading from pages. Like I said, unnecessary pages shouldn't be read, and this is where you see it at, right? And if it was in a heap, this would always be large because why? It has to read every page, right? So if you see a large, scan and a large logical read, you can probably like guess and say, hey, they probably have a heap on this table, right? Because it's going here and scanning everything, going here and scanning everything, going here and scanning everything. Both of those numbers are big. The scan count and the logical reads are big. So those are the two things that I look at. Like I said, I don't know how I skipped over that, but that's what that is. So let's go back to the checklist. So see how long a query ran, see how much rows and columns are created. I look at statistics, IO, logical reads for tables with large numbers of logical reads, right? And like I said, ideally single digit reads are best unless dealing with massive amounts of data, right? And we're not dealing with massive amounts of data here. Remember I told you, the first thing I collect is how much rows was read, 7,641 rows, and all of them being digits. That's not a large amount of data. So I see this and I know there's something I can do about it. So I collect that as well, right? If any, get index hints for guidance on tables and columns that need indexes. So what's an index hint? Do you guys see this green thing right here? Missing index, impact, create non-clustered. That's what an index is, right? So remember I told you the query optimizer, that's one of the questions the query optimizer asks. Are there any indexes on this table that I can use, right? So it knows that, you know, indexes are good, right? So it's asking itself that if it doesn't see it, you know, it's gonna tell you like, hey, I don't see any clustered indexes or non-clustered indexes here. And I think it would really help this query out, right? So the best way I like to describe this is think of a manager again, right? And the manager, after the workday, he writes down things for his manager. Everybody has a boss, right? He writes down things for his manager. things I need for the next workday, right? This is what he's saying. He's saying, hey, it was pretty hard for our guys out there today because this missing index was not there. Is there any way we can get this missing index on there, right? So I will say, like SQL Server, it helps out with a couple of missing indexes, 1 or 2, but it doesn't catch all the missing indexes, right? It's up to you, and I'll show you through this checklist how to basically mimic the missing index, you know, thing in order to find other missing indexes that SQL Server is not giving you. So you don't have to, you know, always have to go to this in order to find missing indexes, or just not find a missing index at all because you're totally relying on, you know, the index sense. All right, so if any, get index sense for guidance on tables and columns that need index, and check XML for extra index sense, right? So this is how you check XML right here. So you go to the green, you right click it, and you show execution plan XML, right? So you go here and you find missing indexes. All right, so missing indexes. So perfect, the missing indexes, and this is XML right here, right? So I work with HTML and stuff in my previous jobs, right? Because I started off as a web developer. So I understand XML and HTML and all that stuff. If the best way to describe this is, you know, whenever you see a slash in the name, that's the end of that value, right? So this is the end of that value right here. And you look for the start of it, which will always be up at the top. So this is the end of it. It's called missing indexes. I look for the beginning of it, which is called missing indexes, right? And so all the missing indexes are housed in between this right here, right? And the reason why I'm looking at this is because SQL Server, if you only look here, they're only giving you one missing index, right? There may be multiple missing indexes that they want you to put on here, but this is only going to give you one. And the crazy thing is, sometimes they're not even giving you the one with the biggest impact, right? So you should always look here to see if there's other missing indexes. Like, for example, this is a perfect example. Missing index impact for this one is 50.293. The one that they showed us, the impact is 48.8008, right? If I wouldn't have went in here and all I did was totally rely on the missing index that was up there, I would not even know about this second missing index that, according to SQL Server, has a bigger impact, right? So it's always good to look in here to find more missing indexes. So that's part of the checklist as well. And that's what I mean by check XML for extra index sense. And that's how you check XML for extra index sense right there. All right, so now that I have all my information, next thing I do is I track down the trouble spots, right? And matter of fact, let's just go through this because I don't want to talk through this. Should I talk through it? You know what? Let me just talk through this really quick and then we'll go through it. So track down trouble spots, right? So using the data collected, read execution plan from right to left, like I told you guys. Read execution plan from right to left, top to bottom when you find a trouble spot you want to track down. And what I mean by trouble spot, right? For example, table post. This is a trouble spot. I absolutely know this is a trouble spot. So I'm going to try to track this down, right? So I read from right to left, top to bottom, and I'm looking for post. So here goes post right here. right? You see that post.pk post ID? And there goes another post right here, post.pk post ID. Both of them are using clustered index scans, right? So I know these are trouble spots right here. I know these are the operators I want to work on right now. And sorry, my head's in the way, but you see that. I know that's what I want to look at right now, because that's the first thing I want to look at, because it's the biggest issue that I've seen here. It has the largest number. So that's my trouble spot. Right? So look at operators that reference the tables and columns collected. That's what I just showed you. Hardest thing to do in large execution planes is to match operators with the part of the query. And it's good to alias this because your table, it's good to alias your tables because of this. Right? And what I mean by that, let me look at the query. So this is the query right here, right? This is post PK post ID, and you see that A right there? That A is an alias. So I look here, join post A, right? So I know this is where I'm looking at for this first operator. And then I can look at the other things like the predicate to find out exactly what it's doing, right? The predicate, think of it as the where clause or the inner join clause. That's what the predicate means, like what it's either querying or what it's joining against, what it's doing exactly, right? So I know I'm in the way. Hold on, let me get out the way. I might need to, I didn't like, hold on, give me a second. Okay. So y'all see that predicate, right? So can y'all see that good, by the way? Can y'all see that predicate good? If anybody can answer.
Yes.
Okay. So here, right, when you look at the predicate, the first thing you're gonna look at is, it says Stack Overflow post community date as A, right? And it's saying community owned date is no, right? And DBO post owner user ID as A, owner user ID is not no, right? So first of all, I know it's A. So I'm gonna look for everything that's A, right? So first of all, A, owner ID is not no, right? So what did I see here? A, user owner ID is not no, that's one of them. I also see A, community owned date is no. What else do I see? Community owned date is no, right? So those are my three predicates right there, right? Those are my three predicates. This right here and this right here. Those are my three predicates that this operator is dealing with. And it's taking 10 seconds. Actually, this is taking 10 minutes. So in order to collect this information where A, community ID is no and A, owner user ID is not no, it's taking 10 minutes to collect that information right now. Obviously, that's an issue, right? So you got to ask yourself, why is this an issue here? So if I look at it, this is a clustered index scan. And what did I tell you about clustered index scan? If they have a primary key, that's automatically used as a clustered index scan. So let's go to post really quick. Columns, the primary is ID, right? So that's the index that's being used. That's what this is saying. It's doing a clustered index scan on this index to get this information. The only thing is though, right? What is this asking for? Like, what does it want to seek? It wants to seek this information. It wants to seek community owned date and owner user ID, right? So wouldn't it be better if we created an index that would cater to what this where statement is trying to get? And that's what this is. That's essentially what you have to think about when you're creating an index, right? Because literally, instead of looking at the clusters, instead of this going into the clustered index scan, it's literally scanning the whole clustered index to get this information, right? To get this where a community is null and a user ID is not null, when it might be a better, option for you to create an index of this, right? And it can go there where it's just like, 1 or 2 columns, 3 columns, and it can go there and collect that information and seek into that information and collect it and, produce it that much more quicker, right? Because like I said, a seek is always better than a scan. A seek is literally seeking into that table. So it's going to seek into null, right? Because it's going to be ordered by that. So it's going to seek into null, and it's going to collect all the nulls. And as soon as null is finished, it's going to jump out of there. With this clustered index scan, it can't do that. It's going to scan the whole table. It's going to scan that whole cluster because it doesn't know where null starts or ends when it comes to community-owned data. And that's the reason why this is taking so long, because it's literally scanning all this information. And thankfully, this is one of the ones that SQL Server is actually suggesting. So that's basically what the query optimizer thinks about when it's creating a suggestion, right? Like I said, they don't, in a lot of queries, they're not going to give you all this. They might give you 1 or 2, but there might be 3 or 4 of these that you have to produce yourself. So you need to understand how the query optimizer is thinking so you can think like the query optimizer and make these as well to improve your queries when you get them. Any questions about this? Mm-hmm.
Yes, so this recommendation, though it's pretty a little bit, I can't really see it properly, but the highlighted recommendation over here, is this something for us to literally take and run as, can you run that as a query? And it kind of produces the cluster index seek that we are actually supposed to use for the query rather than the scan.
Exactly. So if you want to pull this out, you just right click it and go to missing index details. And this is it right here, right? So I suggest that you always change the name of this, right? So let me show you how to, like the syntax, to use the universal syntax is always put in IX. The name of the table, and the column that is going to be in there. Right, and then this has an include, right? So then I say include. And since we're doing this, let me explain to you what this is, right? So if we made this a query, this would literally look like this. It would say select community. It would say select community owned date. Owner user ID. Score from DBO post. Right, and this is the important part, right? So you see these two, they're up here, right? you see this, let me say columns. You see these two columns, they're up here. You see this column score is in the include. All this is saying is that we're gonna order by this community in ascending order and owner user ID in ascending order. And this is the representation of that query. Let me do a select top 1,000. Let me just do a top 1,000 just so you can kind of see it. I don't know what type of information it's going to show, but let's just do this. Community score, okay. Video post. What am I missing? Incorrect. Order community.
Select one. You're doing a select 10,000. Check 10,000.
Yeah.
You're missing order by. You are missing the by.
You said like this.
Say order. You just say order community. You have to put order
The
by.
other by community.
Yeah. So there's
On line 16.
Oh, I missed it. All right, okay, perfect. Thank you. Yeah. Thank you. Thank you. Okay. I think top still has to go here, right? Perfect. Thank you. Hopefully this doesn't take a long time to run because I'm just doing 10,000. But it's looking like it's going to take time to run. You got to remember, this thing has no type of indexes on it, right? So everything that runs on here is going to take a long time. And then something else I did, remember I told you all about the buffer pool. I recycled my buffer pool before I ran this. And remember what I told you, when you recycle the buffer pool, all of that saved, all those saved queries and all of that stuff, they're all recycled, they're all gone, right? So if I ran this previously, it would run quick, but it's looking at it like this has never been ran. So it's literally going to the hard drive in order to collect this data, right? As opposed to going to RAM to collect this data. So just about everything takes super long on this because of that, because there's no indexes on there and there's no buffer pool for some of these queries.
Excuse me, so I wanted to ask a question, but I just wanted you to write a little bit. So when the kind of log that the query is placing on the.
I can barely hear you. You're sounding like you're far away.
Oh, sorry about that. Okay, so I wanted to ask a question, but I just wanted you to write on a little bit, So the kind of lock that the query is placing on the resource, is it gonna like affect the duration and the output in any way? Like, and can we see that also on the execution plan?
You said the type of lock, like no lock you.
Yeah, like you have like a key lock, a page lock, all those kind of lock,
You said key lock. The only thing I know about is no lock, to be honest with you. Are you referring to no lock, or when you say key lock, can you tell me what you mean?
Well, you're talking about like the exclusive locks and all, right? Is that what you're talking about?
Those are weight types. Are you talking about weight types?
No, like
not weight types.
Not
where you put a lock on the table, right?
Yeah, because when you run a script, the first thing the script does is the script put a lock on that resource. Like it might be the table, it might be the page, or whatever. So my question was, is there a way we can read from the execution plan what kind of lock the script is placing, and how would that lock affect the duration or the output of that query?
Right. So on the execution plan itself, you can't see, like, it doesn't specify lock, right? The only way you can see if, a certain operator is locking and, locking that table so nothing else can, is if you do like a live query plan and you look at that and that's the only thing that's running. right? And I hope I understand what your question is, right? So you're saying basically when you run a query, it's locking. Obviously, it's locking the table so it can collect that data. If it's a way to see on the execution plan, you know, where it's locking at is what you're asking, right?
Yes. Yeah.
Okay. So no, they don't have anything that I know of, right? That I've ever seen. But let me tell you this. Let's look at this really quick, right? Because let me go here. There's a where is it at? I have it somewhere over here. You should see post type. There's a website that I'm looking at. I'll probably have the website up actually. Let me see. Yeah, perfect. I have the website up. So this website right here, right, and it's somewhere in my presentation. That's what I was just looking for. But this website right here is the best website that documents all the operators, right?
Mm-hmm.
The reason why, like I said, nothing that I've ever seen, right? There's so much operators. There's nobody that knows, you know, every single operator out there. You know, like I don't care how big you are, you just don't know every single operator. Well, maybe it's some people, who knows? But this is the site that you go to if you wanted to figure that out, right?
Right.
Because this guy lists every operator that exists. So I take that back. There is somebody that knows every operator, and this guy right here. He lists every operator, you know, that's within SSMS, right? Like I said, there's so much operators. You really don't need to know everything. And that's one thing that I wanted to talk about as well on here.
So like I was like, maybe I didn't put my question, like something like I just see an operator there that is like the key lookup. So can you just explain what that is? If you
key lookup?
Mm-hmm.
Definitely, I can explain key lookup. But first of all, let me go because I wanted to explain this, so I'm glad that you brought this up because I have a list of operators that so is good
please,
to know.
If you don't mind, can you just share that link on the chat so that we can look at it our private
time? Yeah, definitely.
And if you can be kind enough to like maybe share this your checklist, because that would be very beautiful.
Yeah, absolutely. I'm going to share the checklist.
All right, thank you.
See. So you guys probably noticed by now, but I obviously don't use Zoom at all, right? So everything is new when it comes to Zoom. All right, but that's it right there. And so one thing I wanted to talk about, and this is on the checklist as well, right? So good list of operators to understand. Like this is the website right here if you want to know the other operators. But these operators, I'll say you should know, right? You should understand the definitions and what it's doing here, right? And key lookup just so happens to be on my list, right? The reason why key lookup is on my list is because what key lookup, when you see key lookup, that means that, you know, you have an index, right? You have a non-clustered index on your table that the query is using, but the key lookup part of it is saying that, hey, these columns are not on that non-clustered index. They're not included in that non-clustered index. That's what that's saying. So whenever you see a key lookup, you think covering index, right? And what I remember, I gave that definition of covering index. That means that there is an index out there that, you know, handles some of your index and handles some of your operator, but there's some columns that you can add to it or cover that will handle the rest of your indexes. or handle the rest of the columns that's calling for that this key lookup is calling for. I have an example. I don't think it's on here, but I have a query that has an example that I can show you. Let me go down. I know I'm kind of jumping now. I'm sorry about that. I didn't know this was going to take this long either, like when it comes to this. Like I said, that's one thing. I made a mistake and I flushed that, I flushed it, unfortunately. And so everything's taking super long because it has no data in there. Let's go here. Let me go to the key lookup one so you can see this example. Okay, here goes the key lookup right here. So let's run this one. Okay. Actually, this one does not have a key lookup. Did I put, no, I didn't put that scan on it. I can probably create a key lookup. Let me see what it's asking for. Asking for display name and location. I know I have an index here. Locations. Hopefully this doesn't perfect. It didn't take a long time. Excellent. All right. So basically, this is, let me just tell you what I did. I just created this index that doesn't have location on it. Now, I didn't test this, obviously. I'm just wanting to show you a key lookup. What this execution plan should show is a key lookup when I run it, because location is not part of this. Even it's calling for location. Perfect. Key lookup right here, right? So what I was trying to explain, right? So it doesn't index seek. It doesn't index seek on display name and it includes reputation, right? But this is also calling for location, right? So location is in the where statement, right? So it needs location. So it's going to use what the query optimizer is going to say is, hey, I'm going to use that index seek because it helps me with part of what I need. But the other portion of it, I'm going to use a key lookup. And all the key lookup is getting that information and it's getting it from the cluster. You see it's key lookup clustered. So it's getting this location, because that's what I left out of it, right? Let me see exactly. I left location out of it, right? So it's getting location from the clustered index, right? But it's going to use the index seek to get the other information that it needs, which is display name and reputation. So it's using that index to get those two, but because location is not in there, it has to use another operator called key lookup to get that. And then the nested loop, it merges those two together, right? And so you see why that would be an issue, right? When it comes to performance, you want to be as good as performance as possible, right? You don't want to do two operators to get information that you can get with just one operator, right? So this is two now. You're using two operators to get information that you can get with one. So here's a covering index, right? Display name is in here and reputation is in here. A covering index is literally adding the columns that's in key lookup to that index, right? And I'm going to rename it. I'm going to just say version 2, because I'm not going to delete it, because the reason why I'm not going to delete that one is because I want to show you that Query Optimizer is going to say, hey, thanks a lot. I'm going to use this one now, because that's the better one out of the 2 indexes. All right, so let me run this. And there you go. Right, so no longer, you don't see 2 things, right? You don't see a key lookup, and you don't see the, I forgot the name of it, I'm sorry. The sort, not the sort, I forgot what it was. It's up here on my list. But there's 2 things that's no longer on here now, right? I wish I remember the name, but you don't see the key lookup especially.
The nested,
so
nested loops.
Exactly, nested loop, thank you. So you don't see the key lookup and you don't see the nested loop. That's 2 things, 2 operators that no longer are needed, which makes the query go that much faster. And that's what a key lookup is. That's an example of a key lookup.
Thank you so much.
No problem. Any other questions? Because I know we're running like, I think we're on the 2nd hour at this point. So you know what I'm going to do? I'm going to go through one example, and after that, we can have any type of questions or anything, because I wanted to go through at least one example from beginning to end. And I know I've been kind of jumping around with this because you guys had like great questions, and I wanted to answer those questions. So let me go through at least one example, and then we can end it off with some questions. All right, so this is the question one. All right, so I ran this one prior. Actually, I want to do one. I'll do another one, because this one is just a second. I want to do one that the post type ID. This one's 12 seconds right now. Okay. So all I'm going to do is go through my checklist, right? So let's say we got this query right here. This query, I ran this query. You see it's 12 seconds, right? Obviously 12 seconds is not a good deal. So I'm going to go through my checklist. Hold on, let me go put this back over previous. Okay, perfect. So the first thing I get is there's 14 rows that was returned. 14 rows returned. I'm looking at the data in these 14 rows. It doesn't look like, a lot, right? So how long did it take? It took 12 seconds to run. 12 seconds. All right. Oh, actually, I forgot. Dang, I didn't run set statistics on. Let me see if I ran set statistics on this one. All right, you know what? We're gonna do this one because I apologize. I didn't run set statistics on that other one. So let's do this one because I ran it on this one. All right. So this one is 1 second. It took 1 second to run. There's one row and it took 1 second. All right, so what do I see in here? This logical reads is up there, right? Especially for that 44,530. I'm gonna collect it.
Okay.
This one. And that one is 90,000. So I'm do that one first. And comments is actually the biggest one. That's a lot. So that one's actually going to be the first one I look at. All right. So I just collected this information, right? This is from Set Statistics IO1 when you run that, right? So looking at this one, I'm like, okay, this is obviously an issue. This is going to be the first thing I want to look at right here, right? So now I'm done with this side. Next thing I go to execution plan. I see that I got a nice little missing index hint, and I see that it's for comments, right? So, okay, I'm like, okay, this is definitely an issue. Like I see logical reads is up there, and I see that SQL Server is telling me, hey, you might want to look into this. So let me get the details for this. All right. So that's that. And the next thing I'm going to do, got the details. I'm going to check XML to see if there's anything else in here. So missing indexes is right here. Missing indexes ends right here, right? So this is it. It looks like they only gave me that one, right? So that's the only missing index that they gave me. Any other missing index, that just means that I have to find myself. Like I have to do the research myself to find any other missing indexes. All right, so next thing is to track down the problem issue, right? The trouble operator I'm going to track down. Like I said, the first thing I want to work on is comments. So I want to look at comments and see what's going on. So remember, you go from right to left, up and down, right? So the very first operator is called users. So looking at it, it takes 3.306 seconds is doing a clustered index scan as well. That might be something I need to look at, right? But like I said, that's not the first thing I'm going to look at. The first thing I want to tackle is comments, right? So I'm going to look for comments. So this is the first one. That's not the one I want to look at right now. Comments right here. This is the one, right? This is the one I want to look at. Let me see if comments is anywhere else as well. These are posts over here. Okay, so it looks like, just looking at this, this looks like the only one that's using comments, right? So now that I'm here, what do I look at? I look at, the time that it took to run. So it took 299 seconds to run. Looking at that's a decent amount of time for one, right? This one took a little bit longer to run though, 306. But they're pointing at this one as being the one that we really need to fix. The thing that really sticks out though is that actual versus estimated, right? Remember I told you that actual versus estimated, there's two ways that you can possibly fix this. There's two issues that you can pinpoint, right? It's either statistics that you need to update and or adding an index to it, right? In order not to waste too much time, I'm not gonna do update statistics because I know the statistics is updated on this. But if I was in, if I was at work, that would be the first thing I'll check out. Matter of fact, I can check it out. I'm just not going to update it. So let's go to it. Let's go to comments. And statistics. This is for the clustered index scan, right? So I'm going to look for the clustered index scan statistics. So this is it right here. PK comments ID. That's the name of it. So let me check this out. This was updated April 17, 2021. Rows and rows sampled is actually different. So what I would do is I would update this with the actual, with a full scan. And let me do that actually. And I'm just gonna save it. Right, so let me save this here as well for my documentation. That's another thing, statistics. Let me just write statistics here. Statistics. Update statistics with full scan. Right, so that's what that is. Right, and what else can I look at when it comes to this? So the predicate is looking for DBO comments user ID as C user ID and row, right? And remember I told you it's good to add an alias to it, right? The alias for this is C. So let's look for this alias of C. Post ID, C user ID, where does it start? Inner join C comments. And this is for user ID, and row. Yeah, so all it's looking for is the joins, right? These are essentially joins are essentially just where statements, where equals whatever. That's all joins are. They're no different from a where statement in the eyes of execution plan. It's no different than a where statement in the eyes of an execution plan, by the way, joins. And let me see, I'm just seeing something different here. The output is, okay, is bitmap, static video comments. User ID, SC user ID. Okay, yeah, so it's basically just for this C user ID, but you also got to look at the output list, which is post ID, score, text, and user ID. So let's look at what SQL Server gave us, right? This is for the comments. So they're saying create a non-clustered index on comments for the user ID and include post ID, score, and text. If you look at this, right, the predicate is looking for user ID. You see that, right? In predicate, oh, I'm sorry. Again, I'm over here blocking. So predicate is looking at user ID, right? That's the first thing. The output, what is going to output is looking at comments, and it's looking at score, it's looking at text, and it's looking at post ID, right? And that's why this was created this way. Something else I didn't tell you actually is the primary key is always added to a non-clustered index. So you don't have to specify the primary key. You can if you want to, but if you create a non-clustered index, the primary key is gonna automatically be added to it anyway. So it's gonna be automatically added by default. So you don't have to specify and say whatever the primary key is. The reason why I tell you that is because in the output list, it is asking for the primary key, which is, I thought it was asking for the primary key. Maybe it's not. Yeah, post ID. No.
Primary key for the non-clustered index?
I take it back. I'm sorry, they're not asking for the primary key, but that is something that I forgot to tell you though. Primary key is automatically added into the non-clustered index. Right, so that's why they're giving you this right here.
Are you saying the primary key is automatically added to the cluster index or to the non-cluster index?
To the non-clustered index. Is automatically, obviously, is definitely added to the clustered index because the clustered index is ordered by the primary ID, right? The primary key. But the non-clustered index is not necessarily ordered by the primary key, but they always add it in there as a default. The primary key is always added in a non-clustered index as a default.
So can you explain what you mean by that? Because I'm kind of like confused what you mean by it's added like a default. What do you mean by that?
Yeah, let me just write it out. Let me just, so literally, this would look like this right here. It would say, like, user ID. And the primary key, I'm pretty sure is called is ID. But let me just make sure in comments, columns, exactly. So it's called ID. So what I mean is this. This is the query representation of this non-clustered index, right? So in that non-clustered index would be user ID, post ID, score, text, and the primary key of ID, even though it's not specified in here, right? You don't see ID specified in here, right? Even though it's not specified in here, the primary key will always be part of the non-clustered index. And that's what I mean. And I wish I had example here where something was calling for the ID and, SQL Server. So for example, if this was calling for the ID, if this right here, this operator was calling for the ID as well, you see it's calling for all of these other things, right? It's calling for user ID, post ID, score, and text. If it was calling for ID as well, this clustered index that they gave you, this right here, this suggestion would look exactly the same. Nothing would change here. This would look the exact same. The reason why this would look the exact same is because SQL Server knows that ID is automatically added because it's a primary key. So they wouldn't add that to this query. They wouldn't add that to this script right here. You wouldn't see ID in here. So it would look exactly like this, even though even if this called for ID.
Oh, okay. Okay. I see now.
Nice. So I'm going to create this clustered index, but I'm going to leave text off of it. And the reason I'm going to leave text off of it, because text is a huge column, has a lot of data in it. Like it's long, long text. I've ran this before. It takes forever to run that index when you add text to it. So I'm going to leave that out of it, and I'm just going to run this without the text. It's going to be a key lookup, basically. What's it called? Comments. Create non-clustered index. Comments, user ID include post ID store. So that's that one, right? So I already know I'm going to create this. Something else I want to look at is post though, before I do anything. So post, I got to look for post. Where's it at? So users is right here, right? That's not it though. So I got to go to the look for this. There go post. Looks like there's two. These are taking 0.003 seconds. These are pretty fast. Actually, they're doing 6. Let's see. Because these are doing 6 right now, I'm not going to worry about it. Even though the logical reads are high right now, because they're doing 6, I'm not going to worry about it right now, right? And like I said, this, what I'm showing you now, I'm not rewriting queries, right? If I saw something like this, this might be a reason to rewrite the query, right? But this, I'm not rewriting queries in, this presentation. I'm just strictly looking for indexes. Maybe another time I can, show how to rewrite queries and stuff. So I'm not going to touch that right now because it's an index seek currently. They're clustered index seeks. And like I said, when it's seeking into the table, that's the most ideal thing that it's doing, right? Seeking into the table. Something that I see is the actual and estimated is 1 of 943. So I told you when the actual and estimated is this far off, this is like 2 off. So if you add 10, that would basically be 10. So my stuff is
Please,
about
Please, can you
100
mute
times.
yourself?
can you mute?
Julian, sorry.
Emma, are you the host? Can you
Oh
mute?
my God. Can you mute, please? Thank you. Sorry, sorry about that, Julian.
Oh, no problem. So remember, one thing I told you that I look at as well is actual versus estimated, right? I see this one is 1 of 943. A general rule of thumb is, you know, if it's about 100 off, you know there's something that could be worked on. And so, you know, if I added times 100 to this, this will be 100, right? So that's 100 off. So two things that I could look at right now, statistics or indexes, right? I'm not going to look at the statistics right now because I know the statistics good. Indexes, obviously, because it's doing a seek. Whenever you see a seek is good, right? Because it's literally seeking into that data. It's not scanning that table or not scanning that cluster. It's seeking into it. So it's seeking into the data that it needs and it's reading from it, right? So if I see that this looks good and I feel like statistics looks good, the only option here is to, if this needs to be fixed at all. I'm not saying this needs to be fixed, but if we, you know, work out everything else and they're still having issues, right? After we add these indexes to it and they're still having issues, I would look at something like this and be like, okay, maybe the query needs to be rewritten here for this right here. So wherever this is happening, maybe the query needs to be rewritten or something needs to happen, or it might just be the case that nothing can happen. This is as good as it gets for this query, right? And so all you can tell the person is, hey, it's having issues over here, but honestly, it's nothing that we can do about it. Like, it's just part of the query. You would either have to take that piece of the query out and figure out another way to get that information, or just accept that this part of the query is going to be this speed here. But anyway, that's the first thing I think about when I see something like this, is maybe the query needs to be rewritten over here. So I'm not going to touch that right now. Let's go to the next one, which is this right here, table users. And this is users right here. So let's see what it's looking for. So the predicate is the equal Aaron Bertrand. And if nobody knows who Aaron Bertrand is, so I'm big in PowerShell as well. Like, I do a lot of PowerShell stuff in automation. Aaron Bertrand, he's basically like a PowerShell guru, and I follow him a lot. And maybe I should explain this as well, my fault. What I'm looking at is I'm looking at the Stack Overflow database, right? So the Stack Overflow database, obviously we all go to Stack Overflow for all kind of stuff. But you know, Aaron Bertrand, I just looked him up because I look up to him. Like, I use him for a lot of my PowerShell stuff. He's a great guy. If anybody does automation PowerShell, especially with PowerShell, I would advise you look at his blogs and all that stuff, because he's probably he's one of the best guys out there when it comes to PowerShell. But anyway, so that's why I'm looking him up. That's the significance of this right here. Where was that? Okay, so what it's saying is the predicate is for Aaron Bertrand. So right here, right? It's doing an index scan on the cluster. What it's asking for, or what, you know, essentially could help this a little bit, you know, shave some numbers, shave some seconds off of this, is if we created a non-clustered index on display names, right? So that's the first part, that's the predicate. Next thing I look at is output. And this is perfect right here. Remember I was telling you that the primary key is automatically added, right? To, and there I go again, I'm all up in the way. The primary key is automatically added to a cluster, a non-clustered index, right? You see the output is ID. I'm not gonna have to add ID to this non-clustered index because it's gonna automatically be put in there once I create it. So this is a perfect example of it being automatically put, and you're gonna see it's not gonna be a key lookup. If ID wasn't gonna be added, you see a key lookup for ID. But when I create this, you won't see a key lookup if I don't add ID. So let me create this right now. The way I usually create stuff, let me just query, let me just take some of this stuff right here. I'm not gonna need to include, I'm just gonna copy and paste this. Create index, and it's gonna be for users table. Users table, and I want the display name. And what else I need to add? And so I'm going to say users here, IX users. Let me take this off. Users. Let me make sure this is all I need to. Let me see if there's any other user object in here. Nah, that's it. So I'm going to run these two. So create non-clustered, I just check it over. So this is the first one I'm going to create. Non-clustered. Cool, let me run this. I don't know what just happened. Hopefully it doesn't take long. Like I said, so one thing I took off of it was text, right? And the reason why is it takes extra long to add text. Because remember, what this is doing is literally creating like a table. It's literally creating a table. Like that's the best way to think about it. It's creating another table, a smaller version of the table that you already have, right? So if I added text to this right now, it'll have to take all that text and insert it into this index, and that will take forever. Hopefully this doesn't take long though. We'll see.
So Julian, while this is running, I do have a
Yeah.
question that I want to ask of timing as well. In a situation, this has to do with the degree of parallelism. So in a situation where you have a 40 processor on a server, what would be the ideal number to set your the degree of parallelism to?
What would be to set max dot to? You're talking about max dot, right? That depends on how much what's it called? It's gonna slip my mind.
The cores?
Exactly, thank you. That depends on how many cores you have, right? So
so in this case, there is 40 cores on this particular server. So what would be the best number to set that to?
the best number to set. when you have 20 cores. I know
40.
there's a rule where I would have to look it up. There's
Okay.
a certain rule of thumb when it comes to this, how many cores you have. So you have 20 cores.
No, I have 40. 40
Oh,
cores.
40.
And
There's a
then
rule of thumb.
it happens that it was literally set to 0, which I think 0 is like the default, right?
Nah, 0 is not the default.
Is it 1?
So max.0 0 is the default.
0 is the default. Hold on, give me a second.
Sure.
Yeah, so max.0 is the default.
Okay. See something.
But in this case, I'm talking about not just the max dub, I'm talking about the degree of parallelism. That's the maximum degree of parallelism.
Right.
Because the number for the degree of parallelism for query that was running on this particular server was literally very high, which was actually causing different wait types as well as causing a lot of blockings during the execution of this particular stop procedure. So when I checked the maximum degree of parallelism, it was literally set to 0 on a 40-core processor.
Right. Okay. So here's the recommendations right here. Right.
Okay.
So less than or equal to 8 logical processors. Keep max stop at or below numbers of logical processors. Right. Greater than 8, keep it at 8. Less than 16, keep stop at or below per of logical processors per NUMA node. Greater than 16. So it depends on the NUMA node and all that stuff. I apologize because at this job, we don't handle that. Like at my previous job, we had to handle this, right? But at this job, we don't deal with, you know, the instance level configuration. But at my previous job, this is what I went by. I went by the recommendations of SQL Server. And matter of fact, on the new versions of SQL Server, they automatically set this. They set the max dot in the when you first build it out. Like this is automatically set depending on how much cores you have.
All right.
If I was you, I'd follow this right here, and let me send you this. And I see Nora said wrap it up.
Yeah.
Because we're kind of over.
Yeah, Julian, this is
So
max dub. This is max dub. I was talking about the maximum degree of parallelism.
It's the
right,
same
maximum
thing.
degree of parallelism is maxed up. Yeah, maxed up and
Yes, Meg,
max.
it's the same thing. It's just a short form. You know, maxed up is just a short form of maximum degree of parallelism.
Okay.
Right. So I would read that right there because, like I said, at my previous job, I did handle that. We handled that, and that's what we use. Like matter of fact, I created a PowerShell script for it and everything where it would calculate it, and depending on what it was, we set it to that with the PowerShell script. That's how we used to do it at my previous job. Like I said, we don't do it at this job here, but that's what I would suggest. You know, go by the SQL Server recommendation, which is listed right over there. So you got to know what type of, you got to know if you have a NUMA node and all that good stuff.
Okay, thank you.
No problem. All right, so I'll go ahead and wrap this up. I wanted to run this query, but who knows how long this query is going to run. We're kind of over. I didn't think it was going to take this long. Y'all had some great questions, though. So I answered as much as possible. Do y'all have any other questions before we wrap this up?
Julian, I just need a clarification with respect to buffer pool cache that you said, since you cleared yours, that's why the queries are taking long. What's the
I can
recommendation
barely hear.
to clear your buffer?
I can barely hear you say that again.
I said when you ran the previous query, you said it took long because you actually cleared your buffer pool. So so how long or how often do we need to clear our buffer pool, or what's the recommendation here?
Let me tell you this. I prefer not to clear the buffer pool, right? Like, keep SQL Server up as long as possible, right? But I know, for example, even in my environment that I work in now, we have a bunch of SQL servers that get restarted every week. I would suggest against that because of things like that, like the buffer pool, different things that's calculated, all of that gets erased and has to be. You see what happened, right? These queries are running super slow because, first of all, they don't have any indexes. And second of all, they're no longer in the buffer pool. So just imagine you have a server that has a bunch of queries. They need to run these things. They need to run fast. They don't have any indexes on it. They're not, the queries are not tuned good. And just imagine you restart that every week. There's going to be one day out the week where everything is just crazy slow because of it, So I suggest, and a lot of people suggest, not restarting that SQL server unless you have to. Of course, when you need to do any type of patching and stuff like that that requires it, you have to do it. But, besides patching and stuff, you shouldn't restart your SQL server on a weekly basis or anything like that. If you're having issues with your SQL server that you have to restart it so queries can run properly, or so, bugs or whatever, you need to figure out what's going on with your SQL server. You need to see, like, do something like this, look at the queries and stuff like that. But yeah, it's no need to restart a SQL server on a daily or weekly or even monthly basis, besides patching and all that good stuff.
Thank you.
No problem. Any other questions?
Hi, Julian.
Yes.
All right. First thing I want to say, wonderful, wonderful presentation. This was fantastic.
Oh, thank you.
You're welcome. Then please, secondly, the steps that your checklist, right? I saw your checklist.
Yes.
Looking good. I don't know how you can get that across to us, all right, via email, like Ima. I don't know, Ima Norris, if he can send that checklist to you guys via email, and then you send it across to everyone.
Yes, definitely. I'll get it across to y'all. Like you said, I can work with Norris or whatever needs to be done, and I can get it across to y'all. Absolutely.
All right, that would be so nice. I mean,
thank you so
much. I appreciate it.
Oh, no problem. Definitely. I'll work with Norris and I'll get it across to y'all.
Yeah, and also just include those your, like your LinkedIn and Facebook, so that we can also socialize with you 1 or 2 times,
Okay, absolutely. Yeah. Definitely.
Thank you so much. We really wish to have you again another time.
Oh yeah, definitely. I'd love to come back.
And we'll be happy to if you can do a presentation on the PowerShare automation. So most of us here will be very interested in that.
Okay, yeah, definitely. Like I said, I love PowerShell automation, especially. So absolutely.
Okay.
So Julian,
So
sorry, go ahead.
Meg, I was just trying to round up. If you have any questions, then
No, I don't have any question. I just wanted to say um, thank you so much to Julian for taking out his time to do this presentation for us. It really means a lot. Performance is something that we always encounter and experience in our daily jobs every day. So coming in here and doing these presentations means a lot to us, and we just want to say thank you for your time. We really do appreciate.
Oh, no problem. Thank you for having me. It was great. Like you can tell, like I spent like a whole extra hour over, so I definitely enjoyed it.
It was totally worth it. Trust me, it was worth it.
Great. I'm
all
glad
right.
to hear.
So, thanks everyone for staying back late, and thank you so much, Julian. So, guys,
Oh, no.
yeah. So, guys, Julian was trying to do something like this out there, so that's why I actually told him to. We're a community here. He should come and just show us what he's trying to do. Some of us might be interesting to join what he's trying to do out there. So just some performance tuning. So if anyone doesn't have any question at this time, I will talk with him if there is anything that he needs us to do to join or whatever, and then we'll just work with him some other time or as soon as possible. So at this time, if there is no other contributions or questions for Julian, I think we are actually over like exactly 1 hour 25 minutes over.
Good.
Yeah.
Yeah, it's 4:25 on my side, so I know I'm not waking up early. I usually wake up early in the morning. I know I'm not waking up early in the morning tomorrow.
Make sure it gets to work earlier.
Yeah, right. Exactly. Yeah.
All right, bro. Thank you so much. Thank you so much.
No problem, man. Great talking to y'all. Great. Like I said, I'll talk to Norris tomorrow to get y'all that checklist